Hi, this is Justin from Chem 2070, and I want to talk about today's experiment and how to use today's data to calculate the percentage of oxygen in air. In this slide, this is apparatus for today's experiment. On the left-hand side, we have a gas burette. Then the gas burette is connected to a rubber tube. And by the other end of the rubber tube, there is the leveling bulb, which is not shown in this picture. The reason we are using leveling bulb is to make sure the pressure on this side of the tube is 1 atmosphere. You just need to keep it in mind in this experiment. Before we begin the experiment, we use a clamp to stop the connection between the rubber tube and the gas burette. And then we remove the stopper, pour in the cobalt solution. Today we use the cobalt solution to react with oxygen in air. Before we start the reaction, we read the level of the solution, which gives us the volume of 10 milliliters. And then we put the stopper on. Now it is a closed system. So now in this system, the air consists of oxygen, nitrogen, and the water vapor. So let's say this blue part of air is nitrogen, and the red part of the air is oxygen. But you have to keep in mind that because there are water in this system, we're using a solution, so there must be water vapor inside the system. So this dark blue one is water vapor. Now we let the reaction begin, and the reaction will begin between the cobalt solution and the oxygen. As the reaction goes, the oxygen will be gone, so the pressure inside the gas burette will decrease. So once we open the clamp, the water from this tube will continuously fill in this burette like this. So right now in this system, the white oxygen has gone, and the only thing left is nitrogen and water vapor. The second reading volume tells us now the volume of the liquid in the system is 20 milliliter, and the reading difference is 10 milliliter. So now I have a question: what's the difference means here? Let's go back to the previous slide. Here, this is what we used up in this reaction. This part is oxygen, but also water vapor, because the oxygen is white. Now we use a rubber band to mark the bottom of the stopper, because this tells us how much gas we have left in the gas burette. It's from here to here. And now we remove the stopper, and we fill in water in the beaker, and we pour the water into the gas burette. before we do that, we record the initial mass of the water under the Baker combined. Let's say it's 80 grams, and after we fill in the water up to the level marked by the rubber band, we have a final mass of 40 grams. The difference of the water, the difference of the mass of the water, can be used to calculate the volume of water we added to the gas burette, and the volume we of water we added to the gas burette should equals the volume of white nitrogen. I'm not going to go back to that picture, but you can go back to look at it yourself. Now the experiment is over, and we have a collection of data. The first data is here, the volume of white oxygen, which is 10 milliliters. And besides, we have, because of today, the pressure of the atmosphere is 725.8 millimeter of mercury, and the pressure of water vapor is 20 millimeter of mercury. We can use this data to calculate how much dry oxygen was in the initial system, because the molarity, the ratio of the molarity of the dry oxygen and the white oxygen can be calculated by the pressure of the dry oxygen over the pressure of the white oxygen. So when we multiply the volume of the white oxygen on the right hand side, we got the volume of the dry oxygen. And then we have the total volume of air, which consists of the dry oxygen, the dry nitrogen, and water vapor. This can be calculated by adding the difference of the first two reading and the volume of dry nitrogen and the water vapor we calculated from the volume of water we added. In this case, the volume of total air is 50 milliliter. And now you should be able to calculate the percentage of oxygen in air, because we have the volume of dry air and the volume of the gas, the air. We have the volume of the dry oxygen and the volume of dry of the air in total. So the ratio is the percentage of the dry oxygen in air. If you still have questions, please come to my office hour. It's on Tuesday, 6 p.m. to 7 p.m. GOH Baker. Thank you.